All right. I think everyone can hear me now. Awesome. Cool. I guess now everyone can hear me. I think I maybe jumped the gun a little bit, but hi everyone, whoever is watching this in streaming land. My name is Brittney Christianson, and I work for Berkeley Yeast. I'm the director of technical sales. A little bit about me is I got my degree background is in food science and fermentation from Oregon State University. Right after school, I started working with a company called Lallemand Brewing, and worked as kind of like a sales rep and a technical sales manager there for quite some time. Got a lot of experience working for them for about 5.5 years. And yeah, and I just at the end of the year made the transition to work for Berkeley Yeast. And for those who might not know what Berkeley Yeast is, we're kind of a newer company, and we focus solely on bioengineered yeast. So having yeast basically do something a little bit more for you guys. And it's been really fun and a great time. So either way, I'm going to jump in now to my presentation, which is called Enhancing Thiol Biotransformation. I think thiols have been such a really popular topic lately, and sometimes it can be kind of complex. I mean, biotransformation and thiols, and you're talking about terpenes and blah 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 and blah blah, and it can just be a lot. So I'm really hopeful that this presentation today could maybe just not simplify things, but hopefully make it a little bit easier to understand. And I hope you guys enjoy this presentation with me. All right. So, what are thiols? Thiols are sulfur-containing compounds, and this is found in so many different kind of tropical fruits, and they're also found in hops, and we also now know that it's found in malt. In hops, it makes about 1% of essential oil in hop cones. Um, I know sulfur probably sounds like it would be pretty bad smelling, but actually, in really small concentrations, it's not really like that stinky, sulfury rotten egg smell. Thiols in various concentrations can range from tropical and fruity all the way to aromas described as I think like cat pee, which might not be as desirable, but the tropical fruity smells are obviously what people are aiming for. This is also what really distinguishes those popular kind of like new school hops. And or people will say the Sauvignon Blanc from New Zealand is also very high in these thiols. And so this is kind of what distinguishes those flavors and those aroma profiles. Um, Very similar to that of grapefruit and passion fruit and guava. So before I jump into, uh, you know, thiols and everything about it, I think we need to take a step back and really talk about thiol precursors. And sometimes people will say thiol precursors or bound thiols is another term. Can be used interchangeably, really. It means the same thing. So precursors, bound thiols, same thing. So where do thiols come from? Thiols are in, as I mentioned, they're in tropical fruits, but we also know that these thiol precursors are found in barley and hops. Um, it's been known that it's in hops, I believe, for the precursors are in hops for a little while now, but there's more recent data that show that there's quite a bit also in barley. The most common thiol compound that is discussed, you'll hear typically is 3-MH. People will say 3-MH precursors. 3-MH is another term that means kind of it's a thiol. So thiol and 3-MH very similar in terms of people will kind of use them interchangeably. But the most common like thiol 3-MH precursors are these cysteinalylated 3-MH and this glutathioneolated thiol precursors. So you can see these two compounds down here at the bottom. And these are known as bound thiols because when they are, there's the 3-MH and it's bound to, and when they're bound, they are non-aromatic, they're not fragrant. And so these plants kind of, or hops and barley have these bound precursors, but you need them to be released into the free version to then be aromatic. So when we're talking about precursors or hops or barley that have a lot of precursors, they don't necessarily smell tropical already. It's the free version that is then aromatic. So the majority of precursor in hops is glut-3-MH. This graph here is about an average of 8 hop cultivars, and it shows that about 92% is of these precursors are in glut-3-MH, and 7% is as the cysteinalylated cis-3-MH. This is really important to note because the current understanding is that yeast is not really able to release thiols from this glut-3-MH precursor yet. So there's a lot of really untapped potential here. Another thing to note is this is really just looking at hop precursors. But this trend is very common with that in malt as well. So you'll see that there's a lot of glutathionylated, the glut-3-MH precursors versus a smaller amount of this cis-3-MH precursor. This slide is looking at showing that even the variety of hops have different levels of precursors. So the last slide was looking at the ratio of the glut versus the cis 3-MH precursors, where this is just looking at the cis 3-MH precursors. And different varieties have different levels of this. This is really just a small sample. You can see that there's some Cascade and some Simcoe and some Citra, but just know that not only can different varieties have different levels, from my understanding, different even like harvest times and different lots, all of this can have varying amounts of cis 3-MH or just 3-MH precursors in general within the hops. So before I jump into thiols completely, I just wanted, there's a lot of talk about like mash hopping, and I think that's like a very trendy thing, and it seems really, really exciting. So the thought is that, or mash hopping is the process of adding hops to the mash, and by adding it to the mash, there's a conversion of this glut-3-MH to the cis-3-MH. As we saw before, and as I mentioned, there's a significant amount of this glut-3-MH versus a smaller amount of this cis-3-MH in hops and in barley. So by adding excuse me, by adding some hops to the mash, the thought is to convert some of that glutathioneolated 3-NH to this cis-3-MH. And so then you can have more. I forgot to mention, I'm really sorry to anyone who's listening. So the thought is because yeast is really only able to use the cis-3-MH version of these hop precursors. It's not able, or just kidding, I did mention it. They're not really able to use the glut-3-MH. They're able to use the cis-3-MH. That is like a usable format. So the thought is by converting this glut-3-MH to more cis-3-MH, now there is more precursors that are readily available for yeast to use. So that's the thought. And what the evidence shows is, I believe, roughly about a 10% conversion of this glut-3-MH to cis-3-MH. So it's not a ton of conversion that's happening, but it is some. I have, and I think that there is evidence that shows that this can lead to more free thiols and end product. I do think that there still needs to be a lot more research on it. Um, I have heard there's also some feedback coming about some people having this kind of bitterness or some kind of vegetal notes, sometimes being like a bell pepper, celery, something kind of like along those notes as well. So to me personally, I just am looking for more data, and hopefully we can also come up with some to really see what is the impact of something like mash hopping, and if it's something that is going to create a huge difference to a final beer product. All right. So we kind of talked about the bound thiols. We talked about the cis-3-MH and the glut-3-MH. And now we are going to talk about how we go from bound to free thiols. All right, so we are going to talk a little bit about carbon sulfur lyase. This is also known, as you see on this slide, I will continue from this point out to call it the CSL, or like a CSL enzyme, which is carbon sulfur lyase. Um, Basically, you'll also see it mentioned as a beta lyase. Beta lyase and CSL are the exact same thing. We're just having like a more descriptive name here. So um, we just feel that it's more descriptive of what's actually going on. We are describing the breakage of a carbon sulfur bond. So beta lyase, carbon sulfur lyase, you'll see them written both ways all throughout the industry. They're the same thing. It's the enzyme that breaks this carbon sulfur bond. Um, but so besides that, this CSL is the enzyme that is needed to break the bond of this precursor to then release this free thiol. And that's really important because, as mentioned before, when it's in a bound version or precursor, it's non-aromatic, it's non-volatile. You're not going to get any of those tropical aromas. But whenever it is a free format, that's whenever it's now a free thiol, and it's going to have those tropical aromas to it. So it's now going to be flavor active. So this is just an example of Berkeley Yeast bioengineered yeast strain. So we inserted a CSL from this probiotic, Citrobacter friendii, and we found that this CSL enzyme was especially good at releasing free thiols. And, so beer brewed with these strains that have this CSL enzyme typically will have that really strong passion fruit guava notes even before like dry hopping, because it will be releasing these bound to free thiols very actively. Okay, so now we're just going to talk about the free thiols. We kind of talked about the precursors. We've talked about the enzyme that's needed and how this enzyme comes from yeast. I probably should mention, and I think we'll get into it in a little bit at a further slide, but all yeast have this, like a beta lyase, a CSL available. The reason why there's so much talk around these genetically engineered strains is because these strains have a much more active enzyme typically. So we'll see in a later slide, but normal yeast strains are not super great at this process of their enzyme isn't super active or whatever. It's not super, it's just they're not as active. So I'll show you a lot of data, but just know to have this like big benefit of thiols or free thiols, more thiols available, it does need to particularly use probably a bioengineered yeast strain just so you can have that effect. So I'll show you in a bit. So most commonly discussed thiols in beer. So when we're discussing thiols, you're probably going to find one of like these four compounds mentioned. There's 3-MH, there's 3-MHA, which is like it's an acetate version of the 3-MH. You have 4-MMP, and then you have 3S and 4-MP. All of these are free aromatic thiol compounds, and these can be perceived at levels as small as parts per trillion. So it's such a small amount that you can actually have a perceived difference. And that's, I think, why thiols have become so popular, and there's so much interest in it, is because just having a small kind of concentration, you're going to have a huge impact on perceived flavor in a final beer product. So on this chart, we have the compound name, we have the compound structure, we have the sensory kind of notes, and then we have the flavor threshold of these compounds. So we have 3-MH, and 3-MH has a flavor threshold of about 60 nanograms per liter in beer. And this has a really distinctive grapefruit, citrusy, kind of almost rhubarb-like aromas. We have 3-MHA, which is a little bit more, I would say, leans more to that kind of guava sensory note. We have 4-MMP, which is typically found in much lower concentrations. And this has a flavor threshold of 4 nanograms per liter. And this people will describe it similar to that of like box tree or like black currant. And then we also have this 3S4-MP, which is also just those very typical kind of tropical flavored aromas. All right. So this chart, it kind of has a lot of information in it. But really what it's showing is the average concentrations of 3-MH and 3-MHA. These are the free aromatic thiols in finished beer. So the graph on the left shows 3-MH production, and the graph on the right shows 3-MHA production. Most of these strains produce close to about 10 parts per billion 3-MH. So there's kind of a few main points that I want to describe here. So if you're looking at the graph, let's talk about the left one first, the 3-MH. You'll see at the bottom that there's London plus CSL, Augustiner plus CSL, Vermont CSL, and Hornindal CSL. So what these are is London is looking at a parent non-genetically modified yeast strain. So, and then there's London, which is plus CSL, which is the bioengineered modified yeast strain that now has this CSL beta lyase enzyme in the strain. The first thing to really notice is the difference between the parent strain and the engineered strain of that same parent strain. So there's a huge difference of concentration of final 3-MH in a beer product from non-engineered versus engineered. This kind of hones on that same point that I mentioned earlier, where unfortunately, a lot of normal yeast strains, they're not as active in releasing these thiols. So having or using a genetically engineered yeast strain is going to make a definite perceived difference if you're looking for these thiol flavors in your end beer product. So that's one point here. I think the other interesting thing on these graphs is looking at that the 4 different engineered strains actually have all varying levels of final thiol concentration in the final beer product. And I do think these beers, they also weren't dry hopped in our studies. So, I think that's also really interesting that it has this much 3-MH without it even being dry hopped. And yeah. This is a really interesting slide. I personally kind of like this one. I think it's just kind of fun of looking at thiol concentration in the guava fruit and then comparing that to thiol concentration in a final beer product. So It's just how it kind of compares and stacks up to actual fruit. So you can see that it's producing relevant amounts of 3-MH, but a lot less of the 3-MHA. Um, and this is why beer fermented with these strains, taste like guava, I think, because it does have these thiols that are comparable to that of a guava fruit. Um, but it also could be that more 3-MHA would potentially boost that guava flavor even more so. Um, this is just an interesting slide. We were kind of curious at Berkeley Yeast to see if we can use a purified precursor that was derived from plants to get a boost of 3-MH in a final beer product. So that's kind of what we did. We purified precursors from from food grade plants, and we added them directly into the fermenter about 24 hours into fermentation. And this was done about, I believe, a 10-barrel scale. And this increased the 3-MH production more than 10 times compared to the no addition control, I would say. And it was hitting more than 100 parts per billion, or I mean, in just translating terms, that's 100,000 parts per trillion, I believe. Um, but either way, I think that this was probably like the max that you would want of thiols. That's kind of a question I get quite often um, is there a limit of thiols? Is there a limit of that flavor where it becomes potentially an off flavor? And I do think that maybe this might be that limit. The beer was it was very tropical, but it just starts leaning into being a little bit too much, too one-sided, just not very well balanced. Um, but it was kind of cool that we felt like we were able to find that ceiling and just kind of have a better understanding of what's an appropriate ratio or what's an appropriate kind of level of these types of flavors in a beer product. So um, this was also something we were really interested in looking at the time course of 3-MH and 3-MHA concentration in beer. Um, during fermentation, beginning at day 4 and then extending all the way to day 32. So we were really interested in trying to figure out how stable are some of these compounds, and are they going to last through? Believe these were just stored in kegs that we were testing, but what is the time course of some of these compounds? So it was really interesting to see that 3-MH is fairly stable throughout this time course, but 3-MHA drops off relatively quickly. And this could have implications for how beer can change, potentially within a month. So if you're producing these beers and within a month you're noticing maybe some of that guava, maybe some of that tropical notes, it's not there as substantially as it was fresh. This can maybe be that reason why. I do think that we're not really sure why 3-MHA degrades, but it's something that we'll definitely need to look into a little bit more and see if we can find more information to then obviously provide um, the industry. But I do think it is a very interesting thing to note, and I think all brewers should be aware of whenever they're producing beers like this. All right. So what does this mean for you guys? Like, you're probably like, cool, Brittney, you told me all about thiols. You told me all about precursors, free thiols, aromatic, blah, blah, blah. You need these yeast strains. Here's how these yeast work by doing this. But like, what does that really mean? How do you enhance tropical flavors at the end of all of this information? What can I use? So this is kind of my takeaway / recommendations for these tropical tasting beers, and like what can and how can you use what information's out there that's usable and like practical, right? So the first thing is lightly kilned malts. So I didn't have it in the slide, but there is research out there that showed that um, malts that were of higher roasting levels actually had significantly less thiol precursors available. So using lightly kilned malts is definitely a recommendation. Mash hopping, I think that's really up to each person. Like I mentioned before, my personal recommendation right now is just like, you know, maybe wait till there, don't change your whole process and let's see more data out there. Um, but I definitely think if like people are all for experimentation, then absolutely go for it. But just keep in mind that there are some you know, potentials to having some more bitterness or astringency or, anything like that as well. Um, but I think the main focus really should be people can um, front load with high precursor hops. So this could be added to Whirlpool. Really anything that is like I said, higher in these precursors. Yeah, there's all these like New Zealand hops, but I think even looking at these American hops as that are higher in precursors as well, kind of like Cascade, Simcoe, and Citra. I think those would be excellent to actually add into the Whirlpool and maybe save those New Zealand hops for dry hopping. I know that those have a lot more free thiols already readily available in them. So really you want to front load with the hops that have high precursors because you need it to, extract the precursors from the hops. So then it's available for the yeast to use when it comes to fermentation. And then at the end for dry hopping, it's better to use hops that already are higher in free, like available thiols. But yes, so front load with hops high in precursors. You want to not probably, you want to use a bioengineered thiol releasing yeast strain. One that has like, an active CSL, beta lyase is really necessary to have a perceived difference from in your final beer product. I usually recommend people to harvest yeast before dry hopping. I say that because dry hopping, you would want to focus more on the thiols that have, or not thiols, sorry, on the hops that have free thiols more than precursors. You don't need to be adding hops that have a ton of precursors for dry hopping. You want the ones that have the free thiols, that have the flavors that are going to go well with your final beer product. You know, don't be adding something like herbal and spicy as a dry hop because it has high precursors. You don't want that. You want it to make sense for your final beer product at the end of the day as well. So I usually say harvest yeast before dry hopping. That also can give you more generations longevity of your yeast pitches, and you don't necessarily need the yeast there when it comes to the dry hop. I also dry hopping rates can vary. Um, and this is where again I've mentioned, but like the dry hopping rates can vary, but use hops that have higher free thiols. That's usually a lot of more of those New Zealand hops. And sometimes there's hops that also have different thiols outside of that of 3-MH, so it can add some more complexity. But there's just like this is like my wrap up slide. Really, it just is saying that, precursors, thiols, this isn't the whole picture, especially when we're talking about hops. Think about like monoterpene alcohols. We talk a lot about linalool and geraniol and citronellol and all of those with thiols and the complexity that hops have. There's so much more to the picture of what is hoppy beer and what is tropical hoppy beer. And it's not always just solely reliant on the trending topic that's going on right now. But, thiols do bring that tropical flavor for sure. I do think that there needs to be a lot more testing that's done, like not only on just, processes for extracting precursors, but also for, having a better idea of what are the precursor kind of thiol, the thiol precursor levels in hops or grain, and having just a better understanding of that and having that readily available in the industry, I think would be so cool. Also, I think another interesting thing it was just touched upon before is that these precursors, bound thiols or unbound thiols, which is the free thiols, these can vary from lot to lot in hops as well, even under the same variety. But yeah, I guess my last touching note here, I feel like I just talked 100 miles per hour, so I'm really sorry for whoever is listening. Um, but the end note is like we still just need experimentation, and experimentation is fun. And, you know, I think there's so much that brewers can do with all of this data that companies like, you know, Berkeley Yeast and these hop companies can provide on these products. But, at the end of the day, you know, brewing is a mix of kind of like art, passion, and science. So it's good to have people who are doing these experiments and are trying these new things and, um, you know, take what you can from us. But sorry, hold on. My laptop is about to die. That would be very bad. Okay. So sorry about that. Um, but yes, so keep on experimenting, keep on trying these things. I do there's so much out there, and I think there's still so much unknown at the same time, and all of these companies who are looking into this are all trying to get more information to provide it to the industry. So that is it. Thank you for everyone who was bearing with me through that whole thing. And also, if anyone has any questions or has any interest in learning more about these thiol releasing, or I guess, yeah, thiol releasing yeast strains, feel free to shoot me an email. It's right here on my slide. Um, yeah, I think that's it. I kind of sped through that. Normally, this presentation takes me, I think, a good 40 minutes, but man, I ran through it. Um, yeah, I don't know if anyone has any questions, but again, if any questions come up later, please just shoot me an email. My email's right here. I believe Andrew's also probably sharing it on the chat. So if there's anything, all right. Thanks, guys.